Experimental investigation of Paver block by using municipal solid waste. Abstract: nowadays municipal solid wastes are increased and it causes a great threat to environment and it decomposes very slowly, that causing lots of pollutions. One of the global environmental impacts of solid waste is the emission of methane, which is regarded as a powerful greenhouse gas, whose impact can be felt within a short period of time. Therefore, utilization of these wastes in making building construction materials can reduce the magnitude of the associated problems. The aim of this project is to reduce environmental pollution by using municipal solid wastes and waste plastic to produce paver blocks. The plastic material is first shredded and melted in a container at a temperature range of 250 ×A × 260 ×A and municipal solid waste and sand was added in the different proportion of 25%, 50%, 75%. The paver block was prepared and tested and results were compared with cement concrete paver block and fly ash paver block of different proportion. Keywords: paver block, municipal solid waste, sand, cement concrete paver block, fly ash paver block. Compressive strength. Introduction. Plastics are used in day-to-day life. At present nearly 56 lakhs tons of plastic wastes are produced in India per year. One plastic is one of the daily increasing useful as well as a hazardous material. At the time of need, plastic is found to be very useful, but after its use, it is simply thrown away, creating all kinds of hazards. Plastic is non-biodegradable, that remains as a hazardous material for more than centuries. The waste plastic will be large in household time too. The common and oldest management of plastic waste in the municipality, as observed in most parts of the country, is through burning and landfilling, which are not environmentally friendly and sustainable, since these may release smoke, carbon dioxide, carbon monoxide, and nitrous oxide, major contributors to global warming, greenhouse gases GHGs, and methane as leachates that contain pathogens. Moreover, landfilling polymer waste such as plastic waste is not desirable, since plastic is non-biodegradable and no economic value would have been derived from the waste in that case. Furthermore, livestock in the municipality may die because they are dieting on plastic waste and being choked. 3. Usually these wastes are either burnt or landfilled. This is an approach which could cause various environmental problems like air pollution, emission of greenhouse gases, and occupation of useful land. The increasing charges of landfill are further aggravating the problem. Moreover, these methods of disposal are certainly wastage of a primary resource. In addition, the biodegradation of these wastes in landfills emits methane, a greenhouse gas which has 72 times heating effect relative to that of CO2. Therefore, utilization of these wastes in making building construction materials can reduce the magnitude of the associated problems. To reduce use of natural resources, and dumping spaces are being achieved through the use of recycled solid waste in building materials. Using waste and recycled materials in concrete mixes for paver blocks becoming increasingly important to manage and treat both the solid waste generated by industry and municipal waste. For this type of pavement will absorb stress, such as small earthquakes, freezes and thaws, and slight ground erosion, by flexing. Therefore, the pavers do not easily crack, break, or buckle like poured asphalt or poured concrete. 5. Thus the results of productive use of waste material represents a means of reducing some of the problems associated with solid waste management. It minimizes the use of natural resources and in some cases results in the production of environmentally friendly products. Fly ash. Fly ash is defined as the finely divided residue resulting from the combustion powdered coal, which is transported from the firebox through the boiler by flue gases. Fly ash is a byproduct of coal-fired electric plants. The fly ash used in the work was of Class C and the specific gravity was 1.99 g/cm3. Plastic. Plastic is a material consisting of any of a wide range of synthetic or semi-synthetic organic that are meltable, and it can be molded into solid objects. Most of the plastics contain organic polymers. The vast majority of these polymers are formed from chains of carbon atoms or with the addition of oxygen, nitrogen, or sulfur. The chains comprise many repeat units, formed from monomers. But generally the level of plastics in waste composition is high. Polymer-modified pavement blocks has applications in road construction and buildings. Hence waste plastic bags can therefore be mixed in concrete mass in some form, without significant effect on its other properties or slight compromise in strength. 6. Municipal solid waste. Municipal solid waste, commonly known as trash or garbage, is the type of waste consisting of everyday items we consume and discard. At present, world produces around approximately 2,378 million tons of municipal solid waste ash, while India at present uses about 256 million tons of as has base material for pavement and used as a replacement in concrete and other application. Also, municipal solid waste ash contains less amount of harmful substances and pollutants. 7. The required amount of sieve analysis helps to determine the particle. Paver block is a paving stone, tile, brick, or brick-like piece of concrete commonly used as exterior flooring. In a factory, concrete pavers are made by pouring a mixture of concrete and some type of coloring agent into a mold of some shape and allowing to set. They are applied by pouring a standard concrete foundation, spreading sand on top, and then laying the pavers in the desired pattern. Pavers can be used to make roads, driveways, patios, walkways, and other outdoor platforms. In order to determine the increase in compressive strength, various mix proportions are made to find the strength of plastic paver block and municipal solid waste block. They were tested by using compressive testing machine. These are the mix proportion which represent the sand, plastics, and sieve municipal waste respectively. Block -1. Paver blocks were casted using mix size distribution of the coarse and fine aggregates. This is done by sieving the paver block mold. V-shaped paver block molds are used for casting paver blocks. The dimension of the paver block is 263.9 mm x x 88.9 mm and the volume of one mold is 0.0016 m3. The height of the mold is to 88.9 mm and the distance between the opposite faces shall be specified size of 263.9 aa plus or minus 0.2 mm. The angle between adjacent internal faces and between internal faces and top and bottom planes of the mold shall be 1200 aa plus or minus 0.50 c. Casting of paver block. Preparation of plastic. When plastic is heated at 120 to 140 oC, it is melted into a liquid form, and this liquid is calculated into a milliliter. If half a kilogram of plastic bags is heated up to a 450 ml of liquid is obtained. Similarly, the mix proportion of plastic ratio is denoted by liquid form, ml. Then the sieved solid waste is added in different proportion. Casting molds are cleaned and oiled before casting, and then they are put on the level area. The molds are filled with the melted plastic that consist of sand and solid waste at different proportion. Then the specimen surface are leveled by trowel. After compacting process, the blocks are demolded and kept for 24 hours in a shelter away from direct sun. The casted paver block was allowed for drying for 24 hours in normal atmospheric temperature. Results and discussion. Compressive strength test. The compressive strength of paver block is one of the most important and useful properties of specimen. In most structural application, paver is used primarily to resist compressive stress. In those cases where strength in tension in shear is of primarily, the compressive strength is frequently used as a measure of these properties. Compressive strength is also used as a qualitative for other properties of hardened concrete. For practically their compressive strength increases as the specimen size decrease. The specimens are kept for 1 day and then it tested in saturated conditions. Specimen are placed in such a manner testing machine that the line of loading is perpendicular to the direction it was cast. Constant load is applied on block till it failure. Conventional paver block. In this study of development of paver blocks from nominal mix design was determined to achieve target strength of M20. Fine aggregate i.e. river sand was replaced completely by sand and coarse aggregates less than 12 mm were used in mix. The final mix was 1:1.42:2.44 and the compressive strength after 28 days curing was determined. Fly ash paver block. In this process use the partial replacement of cement with fly ash in percentage of 0%, 10%, 20%, and 30% respectively. Superplasticizer is used as an admixture which is added 1% by weight of cement constantly in the production of concrete mixture and the compressive strength. It is observed that the compressive strength of conventional M20 grade concrete paver block is 16.28 N/mm2, fly ash based M20 grade paver block is 17.79 N/mm2 and paver block made of waste plastic, sand and solid waste for proportion of 1, 0.5, 0.5 is 13.38 N/mm2. The compressive strength of plastic paver block is comparable with ordinary paver block and it is achieved 82% compressive strength nearer to the ordinary paver block and 75% of fly ash concrete blocks. Hence the addition of 50% of municipal solid waste is effective. Water absorption test, as per is 15658, 2006. The test procedures were followed by IS 15658, 2006. The test specimens were dried in a ventilated oven at 107 AA plus or minus 70 OC for 24 hours. After that the test specimens were completely immersed in water for 24 hours. Then the specimen is taken out from the water and allowed them to dry in room temperature for 2 hours. Then the specimens were wiped off and weighed immediately. The weight of each specimen was noted. The increase in weight as a percentage of the original weight is expressed as its absorption, in percent. The average absorption of the test samples shall not be greater than 5% with no individual unit greater than 7%. The water absorption for conventional concrete block is 3.8% and for fly ash paver block is 4.2%. The water absorption of solid waste paver block has an average of 1.1%. Hence fly ash paver blocks are effective when water absorption is concerned. Cost analysis. Cost of conventional concrete paver block of M20 grade is 12 INR/block. Similarly, the cost of fly ash based M20 grade paver block of same size is 10 INR/block. The cost of solid waste paver block is calculated as 6 INR/block. The cost of solid waste paver block is to be 6 INR/block, which is about half of the cost of conventional concrete paver block. Therefore, the cost of paver block made of plastic waste, sand and municipal solid waste is less than the conventional M20 grade concrete paver block and fly ash paver block. Hence, plastic paver block is economical when compared to the other two. Conclusion. This study was carried out by adding municipal solid waste and sand into melted plastic to develop the lightweight paver block. Municipal solid waste and sand was added in the different proportion of 25%, 50%, 75%. The result shows that addition of 50% of municipal solid waste and 50% of sand with melted plastic shows the good compressive strength. Based on the experimental investigation, it is found that the compressive strength of plastic paver block is comparable with ordinary paver block and it is achieved 82% compressive strength nearer to the ordinary paver block and 75% of fly ash concrete blocks. Hence the addition of 50% of municipal solid waste is effective. The weight of conventional M20 grade concrete paver block is nearly twice than paver block made of plastic waste, sand, solid waste. The weight of paver block made of waste plastic, sand and solid waste increase with increase in addition of fine aggregate. Water absorption of conventional M20 grade concrete paver block and fly ash paver block is nearly thrice than solid waste paver block. The cost of solid waste paver block is calculated as 6 R/block, which is about half of the cost of conventional concrete paver block. Hence the study that conclude addition of 50% of municipal solid waste is effective in account of compressive strength and also economical than the conventional concrete paver block. The utilization of waste plastic in production of paver blocks has productive way of disposal of plastic waste. The recycling of plastic materials will be reduced the environmental degradation. By adopting precast paver block made using plastic waste, ÂÜC and municipal waste have shown better results and benefits.